Well, today you're going to learn about how to MIG weld, at least properly. MIG welding is also called wire feed welding, and wire feed welding is one of the most common types of welding in industry today because it does very clean and low-cost welds, and they're very strong. So first of all, you've got to start off with a full face helmet when you're doing any electrical welding, because the brightness and the electromagnetic rays that are released are much more damaging than anything you've ever experienced by the sun. You can quickly burn your skin and destroy your retinas in your eyes forever. These kind of helmets have a very dark lens. They're perfect for looking at solar eclipses. This kind of eye protection is used for gas welding, like if you're using an acetylene torch or something. That's about 10 times less bright than arc welding, so you don't have to protect your skin from sunburn or anything like that. Now whenever you do arc welding or MIG welding or wire feed welding, and you're going to be welding for more than 5 minutes, always have unprotected skin covered by gloves or long sleeves or something like that, because you will get a sunburn. This particular Miller MIG welder is called the gas feed style, and this particular one doesn't have an option for use with wire feed that has flux core. You have to reverse the polarity when you're using flux core. It's a DC welder, which means it has an AC transformer in it that changes the 110 volt power supply down to a much lower voltage in AC. Then it gets rectified through a diode set and comes out as DC. In the tip of your welding head is the business area, the wire feed tip. If you're using flux core, it has a much bigger hole because there's flux inside the wire, so the wire is thicker. The wire comes on a spool. This happens to be the 10-pound spool. Very often on the wire looks like it's copper. Well, it has a very thin copper coating, and it's only there to prevent corrosion before you use the wire. And of course the wire gets fed out by a slow motor out the other end. The motor speed control is fed by a variable knob from 0% to 100%. Most applications between 70 to 85%. Wire feed speed is the best. Now if you're using gas to do your welding with, you'll do the best welds. The two most common kinds of gas to weld with are carbon dioxide and argon. This particular mixture, which I like to use for doing light jobs, is mostly argon, but it's much more expensive. It does have carbon dioxide in it too. The other gas that's more commonly used in industry and fabrication work is mostly carbon dioxide, and that is best for doing good penetrating welds on thicker metal and structural steel. I like this particular mix because it's good for doing small repairs and sheet metal work, and especially body work. It doesn't penetrate that deep, gives a nice smooth weld, and it's very good for working at low amperages to do, sheet metal work and stuff like that. When your welder's running and you squeeze the trigger, the wire starts to feed out. So this spool just sits there and floats around by itself, and there's a little wheel in here that drives the wire. Right there, this wheel spins. Now there's another wheel on top here. It's just a bearing. When you close this, it squeezes the wire between the two wheels, and then there's a little bit of spring tension here to tension how much pressure the wire has to feed it out. Well, if you have it set for too much down tension, then every time a little weld blob forms on that tip and it sort of welds your wire to the end of the tip, the wire gets stuck for a second. Or if your cable's too twisted up when you're welding, the wire gets stuck too. Well, if the wire gets stuck, the feeding wheel keeps feeding it, and then it all gets jammed up in zigzags here. Well, then you've got to stop welding, get that tip unjammed, cut the wire off, and refeed the new wire all the way through. So that's a real waste of time. So the idea is to have just enough tension that it can shove the wire through no problem, but if something happens and the wire stalls, it can't come out, it will decide to just slip here instead of jamming and bunching up and breaking the wire. The tip size I use in this 130 amp Miller MIG welder is 23 thousandths. But if you want to do bodywork in sheet metal, you can use anywhere from 23 thousandths to 30 thousandths when you're using a gas welder. The reason you have gas coming out around the tip while you're welding is to push away oxygen. Oxygen is a welder's worst nightmare. It absolutely destroys your welds, makes them so brittle and crispy and foamy, they're useless. The shielding gas controls how the weld penetrates and keeps all the oxygen out of the way and prevents oxidizing around your weld. So when you take the cap off your tip, sometimes necessary to clean it because it builds up crust around here, you can see that there's a tube that's got a space around it that the gas flows through, comes out these little holes, it's directed by the copper tip, and comes around the wire tip while you're welding. And that's your ground to complete the circuit. Now my gauges are kind of busted up, but the gauge always closest to the bottle is the one that shows you how much gas is in the bottle. The second gauge is the adjustable one. Well, when you're doing MIG welding, you'd like to adjust the pressure coming out to somewhere between 15 to 35 psi. Of course, the higher you have it set, it works fine, but you want to set it for the least amount of gas to still get a perfect weld, to save money of replacing the gas in the bottle or it'll run out too quick. So that's your wire feed speed. And this is your amperage setting. This one only has 4 positions, but some have an infinite number of positions. It's just a potentiometer. When welding ordinary thickness sheet metal like on a car body, you would most often do it on number 1, sometimes number 2. When you're welding metal up to and close to 1/8 of an inch thick, I would use setting number 3. When I'm welding metal up to 1/4 inch thick, which is the limit of what this welder is good for, I would use position 4. So a wire feed welder that has 130 amps like this one is really only good for metal up to 1/4 inch thick. If you want to weld thicker than that, it's a good idea to use just an AC stick welder or a 220 volt MIG welder that can, or a 550 volt MIG welder, so you can weld up as thick as you want to. The advantage of the gas system is it does the best quality welds. No slag on them, so controllable, it's wonderful. The disadvantage of it is these welders, like I'm showing you here, bottle included, cost at least $1,000 for a name brand one. The advantage of having a flux core job or type of welder is that you can weld outside in wind because the wind isn't blowing your gas away, and they work very well outdoors. This model works horrible outside. But the disadvantage of that other one is welds that just don't look very nice, and they have slag, and they're not smooth and round, they're sort of lumpy. And the flux core welders cost half as much at least, or less. So first thing when you're ready to weld is make sure the way you've got your main feed cable working is it's not too wiggly. You always want it to be as straight as possible, or the curves to be gentle, to prevent the wire from jamming up. Next, on any steel that you're going to weld, these kind of welders do not like to burn through rust or slag like on this hot rolled metal. And the other huge disadvantage of that is it contaminates your weld, makes it very weak. And another disadvantage is that rust and slag both contain oxygen, and that oxygen is released while you're welding and destroys your weld. High amperage stick welders like that actually work pretty good on rusty metal. They burn themselves right through. Now if you were going to weld this piece of metal, you would hold your tip where the wire comes out about 3 millimeters or 1/8 of an inch away from the surface. Of course the surface would be clean, and you would do little zigzags like this, or little curvy zigzags like this, and you'd move about this speed. You'd never just weld in a straight line. Makes a horrible weld that's like sticks up in a high bump and doesn't fuse both surfaces. Always do your little curved or little straight zigzags back and forth. Hold on an angle or hold almost straight. And always try to maintain the same gap, around 1/8 of an inch all the way. So now I'll give you a demonstration. My gas is turned on now, and I'm ready to weld. You can hear it hiss. So there you go. A little wiggle action, you get a good smooth weld. Now if you want to weld sheet metal together, you can't just do a constant line. The metal will distort and warp so much that it'll be too hard to use and too hard to control, and it'll form a big gap and destroy your final product. So you've got to do little tiny tack welds spaced evenly, and then fill in little gaps, like fill in the gap here, fill in a gap there, a gap here. I'll show you what I mean. So we have it tacked in position now, and then you start to do the little welds. Very often you may even need to damp rag it in between when you're doing cars just to cool it off to prevent it from distorting, you know. And I just work my way back and forth. On really thin metal, your welds are just a whole bunch of little tiny dots. It's the only way you can do it without burning it through. On rusty car bodies, it's almost impossible to put two flat edges together because the metal's so thin from rust, or it's just thin because it's body steel. So to put the two flat edges together and try to weld them, they just keep burning apart and falling through. So it's a really good idea to underlap or overlap the metal and then weld it that way. And then if the surface is a little bit too high afterwards, you just tap it with a hammer and bend it down a little and grind a little bit off your weld. You don't want to grind too much. You still want your weld to be strong. Now to tell if you've done a good strong weld, well, that's the upper surface. You want to check the penetration on the back side if it's possible. And as you can see here on the back side, I have some little melting through tiny bit. Well, that shows you have full penetration and your weld is possibly stronger than the original metal is. One more very good idea, if you're using the bottle method of welding, you know, gas welding, always have your bottle laid down unless it's in a cart that's chained into a stand. If your bottle falls over, someone, you know, just trips on the little hose going to it and knocks it over, it can break off the spigot and your bottle can go spinning around the room and might hit you or damage something and waste all your expensive gas. Now these kind of welders can actually weld aluminum and other metals, but the wire is not as stiff as steel wire. So if it had to come all the way through that long cable, it would get bunched up and be jamming up in there all the time. So you get a different hose and a different headset, and it has a little electric motor that spins a spool of, you know, aluminum wire that comes right out here, so it doesn't have to go through a long cable and get jammed, and then it comes out no problem. And you would use a completely different gas if you wanted to weld aluminum with one of these things. So the rules to remember are: use argon gas for sheet metal welding, use carbon dioxide gas for structural and fabrication welding, use flux core welding wire for welding outside in windy areas, or if you don't want to buy the more expensive welder. And also make sure slag and rust is removed from your welding surface. And always make little tack welds to hold your part in exactly the right position for the joints before you start welding, or everything's going to move by heat distortion. Enough said, so get to